Hello. So let's continue from where we left yesterday. We were practicing a few questions and we are going to continue practicing before we move on to the next topic. So the question that we are going to solve today is this: tan 1 degree into tan 2 degrees multiplied with tan 3 degrees and so on up till 89. Now if I want to calculate the value of this expression, we are going to proceed step by step. Let's say the first term is tan 1 degrees, second term is tan 2 degrees, third term is tan 3 degrees, then somewhere in the middle I'll get a term tan 45 degrees. Moving forward, I'll end the series at tan 89 degrees. Okay, so now if I want to solve this, let's see what is the term coming just before tan 45. It will be tan 44 degrees. And what is the term coming just after 45? This will be tan 46 degrees. Now let's observe what's happening over here. The value of tan 45 is 1, so I'll substitute 1 in its place. Now beginning from 1 till 44, I have 44 terms on the left of 45th term, and on the right hand side of the 45th term, I am having 44 terms. Now let's observe how can I write tan 89. If I want to write tan 89, I can write it as tan of 90 minus 1, because 89 is 90 minus 1, so I'll substitute the value of 89 as 90 minus 1. Now as we have studied, because there is pi by 2, 90 degrees, tan will convert into cot 1 degrees. Now 90 minus 1 brings me to the first quadrant. In the first quadrant, all trigonometric ratios are positive, so the SIG and sign over here will be plus. So I'm going to say tan 89 can be substituted with cot 1. So I'm going to write cot 1 in its place. Before tan 89, I'll have tan 88. Similarly, I can call it cot 2. And all the terms are going to follow the same sequence. Tan 46 will be written as cot 44. Now let's see what's happening. If I have tan 1 over here and I have cot 1 over here, tan theta and cot theta are reciprocals. Tan theta into cot theta will give me 1. So tan 1 and cot 1 will give me 1. Then cot 2 multiplied with tan 2 will give me 1. So I am just multiplying 1 how many times? 44 terms over here and 44 terms over here will give me 44 times 1. And then I also have one more 1. So the final answer will be 1 to the power 45, that is 1. I hope that's clear. If you have any doubts, feel free to comment. Okay, let's move forward to the next question. Now if I have to find the value of this expression, that is tan pi by 11, 2 pi by 11, 4 pi by 11, 7 pi by 11, 9 pi by 11 and 10 pi by 11. Let's see how many terms are there. 1, 2, 3, 4, 5 and 6. Because I have 6 terms, it gives me a hint that every term from the extreme ends is going to make a pair with the term from the other end. First term and the last term, second term and the second last term, third term and the third last term. Now let's observe how can I write tan of pi by 11. Can I write it as tan of, I'm going to add and subtract pi, tan pi by 11 plus pi minus pi. So I'm going to write it as tan of pi plus pi by 11 minus pi. Now this can be written as tan of pi plus pi minus 11 pi divided by 11. Finally this will be written as tan of pi minus 10 pi upon 11. Now if I want to convert this, how can I write it? I'll write it as, because there is a multiple of pi, tan will remain tan. Now theta, that is tan pi minus theta, will be written as tan of theta. What is theta? Tan pi by 11. Now if I am subtracting an angle from pi, where does that lead me to? That is the second quadrant. If I am in the second quadrant, what is the sign of tan? It is negative. So I am going to I am going to put a negative sign in front of tan 10 pi by 11. So instead of tan pi by 11, I can say minus tan 10 pi upon 11. Now let's discuss this for the second term. The second term is tan 2 pi by 11. If I am writing tan of 2 pi upon 11, if I add and subtract pi, I will get plus pi minus pi. Now this will be written as tan of pi plus 2 pi by 11 minus pi, and I can write it as tan of pi 2 pi minus 11 pi. What is that? Minus 9 pi by 11, and we can check the answer because over here also I have a 9 pi by 11 term. Now since I have pi over here, tan will remain tan, theta is 9 pi upon 11. Now since I am having tan theta but the angle is pi minus something, now that brings me to the second quadrant where tan is negative. So I'll write minus tan 9 pi by 11 in place of tan 2 pi by 11, minus tan 9 pi upon 11. Now let's observe what will happen to the third term. I'm removing this, I hope you have copied. Now I have tan of 4 pi by 11. I can write it as tan of 4 pi by 11 plus pi minus pi. So it becomes tan of pi plus 4 pi by 11 minus pi. I am going to write it as tan of pi 4 pi minus 11 pi, that is minus 7 pi upon 11. So it will be written as tan of 7 pi by 11 with the negative sign. I'll substitute minus tan of 7 pi by 11. Minus tan theta plus tan theta gets cancelled. Minus tan phi plus tan phi gets cancelled. Minus tan gamma plus tan gamma gets cancelled. So the final answer will be 0. I hope that's clear. If you have any doubt, feel free to comment. Okay, let's move forward. The next question is a sec theta equals 1 minus b tan theta, and the second condition is a square sec square theta equals to 5 plus b square tan square theta. Now I have to eliminate theta from the expression, that is to say I have to solve this expression and the answer should only contain a and b. I have to get an expression that only contains a, b, and it should not contain theta. That is what eliminate theta means. Now let's see how we can solve this question. Okay, so now the first condition says a sec theta equals 1 minus b tan theta. I'll say squaring the first equation. Okay, if I square the first equation, this becomes a square sec square theta equals 1 plus b square tan square theta minus 2b tan theta. Now the second condition gives me the value of a square sec square theta, so I'll substitute that value over here. 5 plus b square tan square theta is equal to 1 plus b square tan square theta minus 2b tan theta. Now b square tan square theta and b square tan square theta from both the sides will get cancelled. I am having this term over here, 2b tan theta is equal to 1 minus 5. So I can say 2b tan theta equals to 1 minus 5. So 2b tan theta is equal to minus 4. I'll bring this entire thing down. So I'll say tan theta equals to minus 4 upon 2b, tan theta equals to minus 2 upon b. Now this is the value of tan theta. Tan theta equals minus 2 upon b. Since I have to eliminate theta, so I can use this value to substitute a term of b in place of terms of theta. I'll just change the color so that it is better visible. Okay, now I have to substitute the value of tan theta. I'll use the second equation for the substitution process. A square sec square theta equals to 5 plus b square tan square theta. I have the value of tan theta with me, so I have to convert this into tan theta. A square 1 plus tan square theta equals to 5 plus b square tan square theta. Now tan theta equals minus 2 upon b. I'll substitute it. I'll get a square 1 plus tan square theta is 4 upon b square. So I'm going to write 4 upon b square equals 5 plus b square into tan square theta, that is 4 upon b square. If I square both the sides, I'm going to get tan square theta equals to 4 upon b square. So now let's see what's happening over here. I'll multiply a square, so it is a square plus 4a square upon b square equals to 5. This and this gets cancelled, plus 4, that is 9 over here. So the final answer would look like a square b square plus 4a square equals to 9b square. So I can write it as I'll take this term over on that side. 9b square minus 4a square equals to a square b square. This can also be manipulated into different forms depending upon the options as you get in your question paper. Okay, I hope that's clear. If you have any doubts, feel free to comment. Okay, let's move forward. Now I have a different question. Now this is a series. Let's count the number of terms which are present over here. That is 1, 2, 3, 4, 5, 6, 7 and 8. Now as we observe, we know the value of cos 30. We also know the value of cos 150. But since they are present in a series, that means there has to be something which is relating the first element with the last one, the second term with the second last one, and so on. Let's try to convert cos 10 and see how it can look. If I write cos 10 as cos of 180 minus 170. Now since I have pi over here, cos will remain cos, so I'm going to write cos theta, that is 170. Now it is pi minus 170. Now that brings me to the, if I am writing pi minus theta, where does that bring me? It brings me to the second quadrant, and cos in the second quadrant is negative. So I'm going to substitute cos 10 with minus cos 170. Instead of cos, I can write minus cos of 170. Now let's have a look at the next term, that is cos 20. So I can write 20 as 180 minus 160. So now this is cos pi minus theta, which can be written as cos of theta, which is 160. Since it is pi minus theta, I am in the second quadrant. In the second quadrant, cos is negative, so I'll put a negative sign. So now I am having the other term as cos of minus cos of 160. Now let's convert the next term, that is cos 30. It can be written as cos of 180 minus 150, cos of pi minus theta, cos remains cos, theta is 150 in this case, and since it is pi minus theta, that's the second quadrant, I'll put a negative sign. So it is going to be minus cos of 150, minus cos of 150. So now we have converted the first three terms for the last three terms. Now this will be the fourth term, that is, okay, I'll do it over here. Cos of 80 can be written as cos of 180 minus 100. So this will become pi minus theta. Since it's a multiple of pi, cos will remain cos and theta is 100. I'm in the second quadrant, so I'll put a negative sign. It's minus cos 100. I'm going to write minus cos of 100. Now if we observe, then cos 170 and minus cos 170 will get cancelled. Minus cos 160 and cos 160 will get cancelled. Minus cos 150, cos 150 gets cancelled. Minus cos 100 and cos 100 will get cancelled. So the final answer what I'll get is 0. If you have any doubts, please comment. Okay, let's proceed. So now this is the next question of the same type. Let's see what's happening. There are 6 terms over here, and as we did in the previous question, the extreme terms are going to form a pair and will lead to a result. That is what the answer would be. So let's try to convert the first term. I'm going to write tan of pi upon 11. If I have to convert this term, so what will I do? I'll add and subtract. I think we have done this question. Let me just check. I think this was done before. Yes, this was the same question which we did before. Pi, 2 pi, 4 pi, 7 pi, and this is the same one. Pi, 2 pi, 4 pi, yep. This question was already done before. This is the same thing. I'll move on to the next question. Okay. Let's solve this one. This is sin x plus cos x upon cos cube x. We have to prove that the LHS is equal to RHS. Now if I want to prove this, I'm going to use LHS first. So let's see how can we solve this question. Left hand side is sin x upon cos cube x plus cos x upon cos cube x. Now this can be written as sin upon cos is tan x. 1 upon cos square x can be written as sec square x plus sec square x. So now I can say it is tan x plus 1 multiplied with sec square x. Now sec square x can be written as tan square x plus 1. So I'm going to write tan x plus 1 multiplied with tan square x plus 1. So now I have tan x plus 1 and I have tan square x plus 1. I'll take tan x and distribute it over the term. This will become tan cube x plus tan x plus tan square x plus 1. Tan cube x plus tan square x plus tan x plus 1. This is equal to RHS. Hence proved. I hope that's clear. So let's end the discussion today and we'll start with the sum of angles, that will be sin A plus B, sin A minus B. We'll understand from where do we get the formulas and how do we apply them. Thank you.